Hi. So we were rudely interrupted by the pandemic and we are losing some time because of it. So I wanted to just take a minute and wrap up the question that we had started in class today. So we started today by looking at projectiles launched at angles. We discovered that the motion of a projectile is affected by gravity in the y direction, in other words, in the vertical direction, but the horizontal motion of a projectile is not affected by gravity. So the only equation that we have to analyze the horizontal motion is the velocity equation, delta x equals vx times t, where vx is at horizontal velocity and it isn't changing throughout the flight. And in the y direction, since it's in free fall, we can use all of our free fall equations. All right, so here's the problem that we're trying to solve. A ball rolls off a table that's 0.6 meters high with a speed of 5 meters per second. How far from the table does it strike the ground? So it is essentially a projectile that's already at the top of its flight. It starts off at the top of on the table and rolls off. As it falls, it will continue to move at 5 meters per second to the right the entire time, but it will speed up in the y direction. It'll go faster and faster in the y direction. Our goal is to figure out that the horizontal displacement, delta x. And so since the only equation that we have is delta x equals vx times t, the two things we need to know are the horizontal velocity and the time in the air. Well, we already know the horizontal velocity. That was one of our givens. It's that 5 meters per second. And so what we need to do is use the y information to figure out the time in the air. And so by y information, I mean the y displacement, the initial y velocity, and the y acceleration. Okay, so let's do that. So step one. Okay, so we're going to need an equation that has time in it. Sorry to be scrolling all over the place. And so the equations that we could use to find the time are delta y equals vi y t plus 1 f a t squared, which is the one we're going to use, and it's the one we use most often, or vfy equals viy plus at. We very rarely know the velocity when it strikes the ground, so we'll use that first equation since we do know everything in that equation other than time. Okay, so we're looking for the time. The initial y velocity is 0. That means that the instant it leaves the table, it's not yet, it has no vertical component to its velocity. So that whole first term is equal to 0. Okay, so I'm going to isolate t. So multiply both sides by 2. Divide both sides by a. And I take the square root of both sides. So there's the equation for the time. And then we can plug in. Oops, we're using 10. Okay, so we see that the time in the air, 2 times 0.6 divided by 10 square root is 0.34. All right, so now we've found how long it takes the ball to fall from the table to the ground. And notice that since this time doesn't depend on that horizontal velocity, then that's why, like in this thing that we saw in class, that's why the time it takes to hit the ground will be the same whether it's dropped or launched horizontally, because in both cases, the time in the air isn't affected by that horizontal speed. Now that we've found the time in the air, we will use that to figure out delta x. So Vx is that horizontal velocity, 5 meters per second. Time we now know is 0.346 seconds. So we get 1.73 meters. All right, so that is that. All right, so let's move on to problem 2. So in this problem, we are going to have a photographer who drops the camera. From a helicopter. Let's say it's moving at 85 meters per second. The camera travels 350 meters horizontally as it falls. How high was the helicopter? Okay, so let's start with a little diagram, what's happening, so we can organize our givens. So here's our helicopter. And here's the camera that was dropped. And so the camera is going to follow a parabola as it falls. The camera's initial velocity the instant it leaves the helicopter will be the same as the helicopter's velocity. And the question is, how far does it fall vertically if we know how far it travels horizontally? Okay, so what are our givens? We know the x velocity is 85 meters per second. We know that the horizontal displacement as it falls is 350 meters. We know the acceleration in the y direction is negative g, which is negative 10 meters per second squared. We know the initial y velocity is 0 at the instant it's released. And we're looking for delta y, the vertical displacement of the camera as it falls. Okay, so in this case, we actually don't have, we're going to basically do the last problem backwards. We're going to start by finding the time using the x information and then applying it to the y. So again, our first step will be finding the time. Oh, this is unfortunate. So in this case, since we know the x displacement and we know Vx, we will use those to solve for time. Okay, so that was 350 and 85. So the camera was falling for 4.12 seconds, and then we'll apply that to the y direction to figure out how high it must have been to take 4.12 seconds to fall. Okay, so it was dropped from rest, so VIY is 0. All right, so that number squared times 5 is 84 point. Not the highest helicopter, but at least it's somewhat realistic, I guess. So this actually comes out negative, right? Because I have 1/2 -10 times the times squared. And so this is describing the vertical displacement of the camera. And so since the question asks how high was the helicopter, then strictly speaking, the helicopter was 84.78 meters above the ground. So really that's the quote answer here. Okay, so we won't do a lot of problem solving. Honestly, this is about it for this unit, for this type of question. But it's just basically a refresher on using kinematic equations for free fall with now the additional twist of using the y information and the x information in tandem, where the thing that links them is the time. That's all I got. I'll see you later.